Hi guys, welcome back to the channel. Today we are going to be looking at a specific problem. So let's take a look at this problem. Now this says the function below has at least one rational root. Find the y-intercept and use the rational roots theorem to find all the rational roots, and fill in the sign table and sketch your graph below. Your graph must accurately cross all known intercepts. So this comes from pre-calc, and what this problem is essentially doing is trying to get you to learn how to graph polynomials. Since you have to find all the known intercepts, the easiest thing to do is just to start by finding the y-intercept. So in order to do that, you know that every y-intercept has the value of x as 0. So plug in 0 into the function for x and you will get your y-intercept. So here we do the math and we get f of 0 equals 15. So your y-intercept is at 0, 15. Okay, now you have to find all the roots, all the possible roots. And the way to do that is by using the rational roots theorem, which says that take the factors of the constant term. So our constant is going to be 15, and it's going to be plus or minus 15. And then we take the factors of the leading coefficient, and our leading coefficient is with the x to the power of 4. So that would be a 1. So now we have possible roots equals plus or minus factors of 15 divided by plus or minus factors of 1. So factors of 15 could be 1, plus or minus 1, plus or minus 15, plus or minus 3, plus or minus 5. And now factors of 1 is just going to be plus or minus 1. So if you take each of those and divide by 1, you essentially get the same thing. Now, in order to find your zeros, you can easily plug in one of those to try to see if your answer is going to be a 0. If your output is 0, then you know that at that point, you have a root. So check that. Let's take the first one, right? So let's take x equals 1. We're going to check that and see if we get 0 as an output. So we plug it in and we do the math and we get 32. So 32 does not equal 0, which means that x equals 1 is not a root. What about -1? If we plug that in, we do the math, we get the output is 0. So x equals -1 is a root. Now, when it is a root, you can start doing synthetic division. These are the steps for synthetic division. You put in a -1, and then you put all the coefficients of your polynomial. Your remainder is 0. That's great. That's what you want. So now rewrite what you just did synthetic division for. So you're going to have x plus 1 times x cubed minus 7x squared plus 7x plus 15. After you perform synthetic division, remember you always want to subtract 1 degree from each of your terms. Okay, so now what I want you to do is check x equals -1 again. Usually problems like this always follow that pattern. So plug in a -1 into your equation, and we're going to get f of -1 equals -1 to the power of 3 minus 7 times -1 squared plus 7 times -1 plus 15. And yes, this is great. It equals 0, so you know that x equals -1 is a root again. So we're going to perform synthetic division with -1 again. So now we perform synthetic division. Remember that for synthetic division, the first number always gets brought down. You don't do anything to that number. So we're going to bring down the 1. Here's the math. You're going to end up with remainder 0. So now rewrite what you just did synthetic division for, and you're going to get x plus 1 times x squared minus 8x plus 15. Now you're going to try to factor that x squared by using the big X. And you're going to end up with x plus 1 times x minus 5 times x minus 3. But remember, your first synthetic division showed you that you had x plus 1 as a root. So for your final answer, you're actually going to have to square that x plus 1. So what that means is you're going to have roots at x equals negative 1 with a multiplicity of 2. Usually multiplicity for graphs, for polynomials, shows you that at that point, you're going to like bounce off the root. So I'll show you what that means in a little bit. You're going to have roots at x equals 3 and x equals 5. Now, for your sign chart, you're going to look at intervals. So the way to do your intervals is starting from all the way to the left. So all the way to the left, you're coming from negative infinity to your first root, which is a negative 1. So your interval is going to be negative infinity to negative 1. Now pick a point. Pick like x equals negative 2. Plug that into your original equation and see what your output is. So if we plug in negative 2, we get equals 35. That's positive, so that's going to be greater than 0. Continue the process. You can pause the video to do the math here. But essentially, you're going to end up with this on your sign chart. You're going to have positive, positive, negative, positive. Now, when you graph, you should have all your roots and your y-intercept plotted. So now the sign chart tells us that we're coming from negative infinity and we're approaching our first root. So that's negative 1. And all those points are positive. So you're going to be above the x-axis. Now notice that at x equals negative 1, we had multiplicity 2. So that means that at the root at negative 1, we're going to sort of bounce off the point instead of going straight through it. And then you continue the process for all your other roots. And you're going to end up with a graph that sort of looks like this. So this is a rough sketch, right? Now let's compare it to the actual graph. So this is the actual graph from Desmos. And you can see that our pattern is quite similar. So you know that you've done this problem correct. If you want to see any other videos, let me know. Thank you so much for watching, and like and subscribe, please.